So this morning we have a 2008 Hyundai Accent, and it's here for a noisy wheel bearing. It sounds like the noise is coming from the left front, so we're going to set up to see if we can hear that. Sometimes the wheel bearing noise is obvious enough that you can tell exactly what side it's coming from, or there's play in the wheel bearing. In this case there isn't. But what I like to do to find or try to isolate which side it is and what corner it is to grab the coil spring with your hand and squeeze it as tight as you can, and then try spinning the wheel, and you can feel the vibration in the coil spring amplified in the coil spring. So this side is definitely rough. I don't know if the camera is going to record that, but like I said, just squeeze the coil spring with your hand and then spin the wheel. That usually helps you isolate what side it is. Running on the hoist nowadays, although this car probably doesn't have traction control and ABS, it's just crazy. You try to run the vehicle on the hoist, and then you got to deal with ABS, traction control, all-wheel drive codes, and you know, it goes into traction control mode even if you try to turn it off. It's not worth it. So the brakes are in pretty decent shape on this thing. Let's even get a light in here so you can see it. So we're going to take the whole brake caliper and bracket off as an assembly and leave it all as one assembly. Hang it up from the strut. We need to remove the rotor and the castellated nut here. And this has got a pressed-in bearing, so we're going to show you how to replace a pressed-in bearing with some special service tools. So once the brake caliper is off to the side, you can hang it with a hook of some kind or a tie wrap. We got to remove these tapered Phillips screws. Hit the rotor a couple times to dislodge the screws, and use an impact screwdriver to break them loose. I find if you hit the rotor a couple times, you have less tendency to break the tip of the impact screwdriver. Let's save these. Wow, that's in there good. Save these screws because we got to reuse them. And save the brake rotor. Brake rotor is in pretty decent shape. So we'll pick up when we got some more pieces off. So we do have to disconnect the knuckle here, and I see that this has a bolted on ball joint, so ideally remove these two bolts from the lower ball joint. If we take it apart at the upper knuckle, we're going to disturb the camber adjustment, and that might require alignment, although technically you're supposed to have an alignment performed after any front end work or disassembly or disturbance, but less likely to disturb anything by removing these two lower bolts. I don't want to take the taper out of here because it's got two simple bolts here. So got to get the knuckle away far enough to get the CV shaft out of the bearing assembly. So once the two ball joint bolts are removed and the axle nut is removed so that the axle shaft can be pressed in, we're going to put a small chain under the control arm and a bar up against the bottom and push down on the control arm while we move the ball joint off to one side. So that should be enough now to get the axle shaft out. Just watch your brake hoses that you don't stress it at the end of its travel. Now I'm going to have to get at this from a different angle. Tap this bolt in. So once the axle shaft is removed, you can hear this bearing. It's pretty loud. Problem with this bearing is it's going to have the snap ring on the inboard side. Although it looks pretty clean, it may be difficult to remove that. So I'm going to spray that with some penetrating fluid so it can soak a bit. And we use the hub tamer to pull this flange off. So normally I would use this hub tamer to pull the flange out, but a couple of problems. It needs to push up against here and it's going to bend this shield. So I decided to opt for a slide hammer approach here because I don't think it's going to be that tight. So as you can see, the slide hammer worked just fine to pull it out. And now we have to pull that bearing race off. I should have done that before I pulled the bolt. I had to put the bolts back in the lower ball joint to hold the assembly in there. So this bearing is actually pressed in, so I have to access the snap ring in the back here. So there's a snap ring out of the back of the bearing assembly. Spray with penetrating fluid and get a screwdriver underneath one end of it. Try to tap it, release it from the rust. Now this bearing can be pressed in. It presses this way to press out. Let's look at the new bearing. Here's the new bearing assembly. This one doesn't have a speed sensor reluctor built into it. It's a double sealed roller bearing, so it can go in either direction. You have to watch because some systems have a magnetic reluctor on one side, but this one does not. So there's the Astro hub tamer installed in such a manner to push the bearing out that way into this cup. And I usually use an impact gun to take it apart, but I use just a ratchet to put it back together again. So we'll see if this will work. Oh, that wasn't good. Okay, let's hang that back up there. But it's coming off anyways. Well, that pulls the bearing out. Pretty easily. There's the assembly with the bearing in it. Now we just got to clean up this housing and press the bearing back in. But like I said, I use hand tools to press it back in. So when you're choosing an adapter to press this back in, you want to make sure you're pressing on the outer race of this bearing, not the inside. You'll damage the seal here. So I picked this one at first, but it might be a little bit too small. So I went to the next one, which is just right. And you want to make sure that it's going to fit inside here and not be pressed into the case. So it goes in past the snap ring, so that's good. So that should work. I'll show you what that setup looks like when it's on the vehicle. So there's the race, or the bearing, on the vehicle with the adapter. And like I said, I like to pull it in by hand because you can control things better. You can feel when it's getting tight, if it's binding or anything. Put a little bit of gear oil on the friction surfaces of those hardened steel washers, helps as well. And this just pulls in until it bottoms out. I've already cleaned out the snap ring groove. And I have a new snap ring as well. Too warm for this morning. Okay, that seems to be bottomed out. We'll take it off and have a look at it. So there's the new snap ring installed in there. It is a bit of a challenge to get that in. These snap ring pliers that I purchased from Napa, they're Ultra Pro. I know part number is worn off of them. They allow you to basically screw the snap ring in until it fits and then put it on into the knuckle like that. So next we have to press this inner bearing race, a portion of the bearing, off of the hub. So I'm using this split flange here, and I'm going to snug it up and put it in the press. So here's the setup in the press to press the bearing out. Use a suitable driver. I'm going to have to reposition this. I can see it's a little crooked. It might move over. Press that flange or the inner portion of the bearing off. There we go. Now we can press this back into the bearing assembly. So basically it's the same procedure as pressing the bearing in, but now you're pressing the hub into the bearing. So you got a backing spacer in the back and the same screw through. And again, do it by hand so that you can feel if it's going in square. You won't Brunel the bearing if you use hand tools. And this just goes in until it's bottomed and the CV shaft retains the bearing. Clamps it together, and the torque on the CV nut either preloads the bearing or establishes the load on the bearing. That's bottomed out. I could feel it stop. Might as well loosen it off. And we'll take the tool off. So that feels nice and smooth now. And basically from here it's just a reverse procedure of the disassembly. Put the CV shaft back in, reattach the lower ball joint, torque the nuts, put the brake rotor back on, caliper back on, torque the axle nut. I'll find the specs for those. So there it is all back together. The torque on this axle nut, and I put a little Loctite on it, is 147 to 184. So I would suggest to tighten it up to about 160 and then tighten it as necessary to line up the cotter pin hole. The lower ball joint retaining bolts are 43 to 52 foot-pounds, so 52 is good. And the caliper bolts are the same, caliper mount bolts, that is. So, good to put the wheel back on and go for a road test.